On this video, we're gonna see how to go from a single logarithm, and it's not actually combined on this one. We're actually gonna expand the expression as much as possible. So let's get started. We have a base 10 logarithm. So as you know, you can write it, or you can choose just to go ahead and write the common logarithm as you see now. Then you're gonna, instead of writing this as a radical with an index 5, we're going to write it as 1/5. So that's x to the third, y to the fourth power, divided by z and 6 as the exponent, and all of that raised to the power of 1/5. Then, this is one way of doing it. We can multiply 1/5 by every exponent that we have on all variables. So this will convert into x raised to the power of 3 times 1/5 is 3/5. Then we're going to have y raised to the power of 4/5. Everything divided by z. Let me expand that parentheses. Raised to the power of 6/5. Sometimes it's possible to reduce the fractions. In this case, we won't be able to do anything to them, so we're just going to keep going. And now we're going to be using those two laws. So any multiplication expands to an addition or a sum of two logarithms, and any division, the one that's dividing, is going to be a negative logarithm. So basically, we're going to have a positive logarithm with x raised to the power of 3/5, another positive logarithm with y raised to the power of 4/5, and then a negative logarithm with z raised to the power of 6/5. Now we have to do something to those exponents by using this law, the first one that we have listed. So that would make the first one 3/5 times the common logarithm of just x, then 4/5 times the common logarithm of just y, minus 6/5 times the common logarithm of z. This is our final answer, but someone could express this in a different way. Perhaps if someone brought down the 1/5 as the coefficient or as a multiplying factor prior to the logarithm, the answer can also be expressed as, if you factor the 1/5, or if you bring down that exponent at the beginning, you're going to have 1/5 that multiplies 3 times the common logarithm of x plus 4 times the common logarithm of y minus 6 times the common logarithm of z. But this answer is good enough, and it'll do just fine. But if someone had this as 1/5 that multiplies the common logarithm of x to the third, y to the fourth, and z to the sixth, this is another way to go. You could go from here, expand, but everything that you expand will be multiplied by 1/5. And you would end up with something like this. But I think both answers will do just fine.